Hello and welcome. In this video, we'll talk about factoring polynomials. There are two big and important theorems that are involved in the process of polynomial factorization: the remainder theorem and the factor theorem. You already looked at the remainder theorem in the previous lesson when we investigated the whole process of how we derive it. But just to recap one more time, we said that when a polynomial f of x is divided by a binomial of the form x minus b, then the remainder would equal the value of the polynomial at b. We called this the integral form of the remainder theorem, and that is because the value of b is an integer. When a polynomial f of x is divided by ax minus b, we said that the remainder would equal the value of the polynomial at b over a, and this is what we call the rational form of the remainder theorem. And the reason why is because b over a here is in ratio, in rational form, so it's a fraction. So when it comes to the factor theorem, we won't go that far away from the remainder theorem because, as a matter of fact, the factor theorem is just a special case of the remainder theorem. Now, when we say the word factor, we think of two numbers that multiply each other to give a certain product. So we say that 3 times 2, for example, equals 6. And in this case, we're going to say that numbers 3 and 2 are factors of 6. If we divided number 6 by either one of these factors, the answer will be a quotient with no remainder. So if you divide 6 by 2, you get 3, no remainder. If you divide 6 by 3, you get 2, no remainder. And that is what's special about factors. So the factors will divide a number evenly with no remainder. When it comes to polynomials, we're going to say that a binomial of the form x minus b would be considered to be a factor of a polynomial if the remainder that we obtain from the division of f of x by x minus b would be equal to 0. Now, remember that the value of the remainder is measured by the value of the function at b. So in other words, we're going to say that x minus b is a factor of f of x if f of b equals 0. This is what we call the integral form of the factor theorem, and that's again because b is an integer. Similar to this, we say that the polynomial f of x has ax minus b as a factor if ax minus b will divide f of x evenly with no remainder. So if the remainder equals 0, which means that the value of the remainder, which is measured as the value of the polynomial at b over a, equals 0. And this would be the rational version of the factor theorem. So that's all factor theorem is about. But how does the factor theorem work? And that's what we are going to look at together now. I took as an example a very familiar polynomial, a second-degree polynomial, which you know how to factor even if you didn't know anything or never heard of remainder and factor theorem, because you have learned how to factor this trinomial in grade 10. The reason I brought in this example is because we know how to factor this with lots of confidence, and what we are going to do is we're going to input or incorporate all the concepts that we have learned from the remainder factor theorem to see how it can work in trinomials as simple as this, or polynomials as simple as this one. So let's get started. If you were to factor this polynomial, then you would say that this is an easy trinomial to factor, x squared plus 5x minus 14. And when I say an easy trinomial to factor, I mean it's a trinomial where the coefficient a is 1. So the way we factored these trinomials was write two sets of brackets and then write x as the first term in each set of brackets. So each set of brackets will host a binomial, which is a factor of the polynomial here. And then we said that we need to find two numbers that would have the sum of 5. Here. Okay. So the sum has to be 5 and the product has to be 14. So we'll write this down, product negative 14 and sum equals 5. And we also mentioned that whenever we try to search for these two numbers, we always start from the two numbers that multiply to negative 14. And that's because there is a limited number of or sets of numbers that will multiply to negative 15. And there is an unlimited set of numbers that can add to 5. So I always tell my students to start by listing the smallest factor possible. So I go 1 times negative 14 and I check and see what the sum would equal. So this won't work. And then you go 2 times negative 7. Check the sum. And that would equal negative 5. So what we have is positive 5. So it seems that we're getting closer. All we have to do is switch the signs around here so that we can switch this sign. So we're going to say negative 2 times positive 7. So that would equal negative 2 plus 7 or positive 5. So we're going to say we've hit the jackpot here. And the two numbers are negative 2 and positive 7. And we said that the order won't matter if you write negative 2 here or in the second set and vice versa for 7. Now, let's think or let's rethink again how we figured out the numbers that we needed to place in here. Remember that x minus 2 now, we can call it a factor of the polynomial. This is a factor, and this is another factor. Okay? And both factors are in the x minus b form. And the way we figured out b in here, which is 2, is by looking into the numbers that multiply to negative 14 or looking into the factors of negative 14. So whenever we search for the values of b, we need to search for the numbers that are factors of the constant term in this trinomial or in this polynomial, we might say as well. The same thing for number 7. So negative 2 and 7 or 2 and negative 7 in this case are obtained by searching or investigating the factors of negative 14. And when it comes to polynomials of more than or degree higher than 2, that we still do the same thing. So in order to figure out the values of b, we always look for the factors of the constant term. So I'm going to write this rule in here. So to determine the possible values of b, we investigate all the possible factors of the constant term in the trinomial. And this is one very important rule you need to keep in mind when factoring polynomials. Okay, So here we are. I am going to box this up because this is so important to remember. Oops. Hopefully it doesn't look bad. Okay, good enough. Now, well, how does this work? Because negative 14 doesn't just have positive 2 and negative 7 as a factor. So how does that really work? How would I do this in a more complicated polynomial? So the way we think about it is this. If we have x squared plus 5x minus 14, and we want a factor, then we're going to point out first at the constant term, which is negative 14. And we'll say that the possible values or the possible factors of 14, which are the possible values of b, are plus or minus 1, plus or minus 2, and plus or minus 7. There are no other factors. And the next thing you want to do is find out what the value of this trinomial will be at each and every number. So we're going to say that f of 1 would equal 1 squared plus 5 times 1 minus 14. That's different than 0. That means that x minus 1, so x minus b, in our case b is 1, is not a factor. Excuse me. And then we search for f of negative 1. And you don't really have to show all this work in writing. You can simply use a calculator for it. So we go negative 1 squared plus 5 times negative 1 minus 14. Again, different than 0. So x minus negative 1, which turns into x plus 1, also not a factor. And then you search for f of 2. You test all the numbers in order because you don't want to miss any, and you don't want to go back and forth and repeat the same calculations. Remember, you are doing all these calculations in a calculator, so you won't actually see the work that you've done, okay? So that's 2 squared plus 10 minus 14, that is 0. Therefore, x minus 2 is a factor. And once you discover the first factor, you can easily divide the polynomial by x minus 2, and then you will get a simpler form of the equation, okay? In this case, actually, it's a bit simpler just because we know we only have 2 factors. And we're going to say that the only number we can place in here would be positive 7, and that's because we need to obtain negative 14, right? So, and that's how we factor polynomials in general. So what we learned from this example is the fact that in order to figure out the factors of a polynomial, we need to search or look into the factors of the constant term. Okay, so let's take a look at a real or a polynomial that we haven't factored in the past. We've never tried. So here we go. What we have here is a cubic function, and what we want to do is factor it. My focus will be on the constant term. Now, 2 things we need to look at. Here we have a coefficient of 1, so that means we only have to focus on the constant term. The constant term is negative 15, and that will help us figure out the possible values of b. I'm only writing everything because I'm trying to explain things. You should too if you like to take notes when you are learning a lesson, but normally you don't really have to write the whole statement here, the possible values of b. It's understandable. So since the constant term is negative 15, then we have plus minus 1, plus minus 3, plus minus 5, and plus minus 15. And now we have to search for the factors. We're going to start with x equals 1, so we're going to find f of 1. F of 1 would be 1 cubed plus 3 times 1 squared minus 13 times 1 minus 15. We don't need to really calculate this with a calculator. Here we have 1 plus 3, 4, and then minus 28. And I immediately can say that's different than 0. So therefore, x minus 1 won't be a factor. It won't work. So we're moving on to the next possibility. We're finding f of negative 1. F of negative 1 will be negative 1 power 3 plus 3 times negative 1 squared minus 13 times negative 1 and then minus 15. So that's negative 1 plus 3 plus 13 minus 15. So that's 16 plus negative 16, 0. So we're going to say since the value of the function at negative 1 is 0, then x minus negative 1, which is basically x plus 1, is a factor. So once you have discovered or found the first factor, once you find the first factor, what you want to do, start dividing the polynomial by your first factor. You want to do this because you want to make your polynomial easier to factor. And in this case, I would use synthetic division. So we have 1, 3, negative 13, negative 15. And negative 1 goes right here. We bring 1 down. 1 times negative 1, negative 1. You add. 2 times negative 1, negative 2. You add. Negative 1 times negative 15 is 15. You add. You get 0. You see how the remainder, one more time, made us happy here. It's 0, so we know that we have found our factor correctly. So the rest of the terms in here will have the variables x squared, x, and the last is a constant term. So we're going to say so far we have managed to find or to factor the polynomial into two factors, x plus 1, x squared plus 2x minus 15. Now, you probably are thinking that, okay, so should I use the factor theorem here? Yes, but why bother when you know how to factor the polynomial by just simply using the knowledge from grade 10? So what I would do is take a shortcut and factor the trinomial by just figuring out two numbers that add to 2 and multiply to negative 15. So these two numbers must be positive 5 and negative 3. And hooray, we have managed to factor our first polynomial here. Okay, moving on to the next example. We are going to take a look at factoring polynomials that have a coefficient different than 1. And I'm going to take a look. I prefer that I do this on a separate, on a separate video. I record it on a separate video, so the lesson won't get too long for you. If you have reached or listened to this point, I would prefer that you practice a couple of examples with polynomials where the coefficient is 1. So that will prepare us to learn how to factor polynomials where the coefficient a is different than 1. The process will be slightly different. Okay, so bye for now and have fun practicing.